Today I'll show how I rigged my portable ice fishing shelter with LED lighting, including instructions on soldering and wiring if you choose to go away from some of the plastic connectors available online. I'll also show how I rigged my 12-volt battery box with a lighted on and off switch and a voltage meter to gauge battery life. Let's start with the materials needed, then the skills to wire your lights however you want to, and finally show how to wire up the battery box. For the LEDs, I have a link to the exact lights I used. These are listed as waterproof. The specific type of LED is 2835, which is a bright white light. You'll also see 5050 and 3825 lights on Amazon or eBay. They either aren't as bright or have multicolor capabilities, which I don't think serves much of a purpose for lighting a flip over. Besides, they often have remotes which you can lose. Here you can see the waterproof coating, and on the back side there's a nice peel and stick adhesive. I'll also be backing my connections with electrical tape. You can get away without doing any soldering at all. The easiest thing to do is to buy cables with the 5.5 by 2.1 millimeter connectors. They make ones like this with an inline on and off switch, as well as ones with splitters to go from one connection to several. On the end nearest the battery, you can cut off the connector and expose the bare wires. Then you can use pliers to crimp on the quick disconnect Spade terminals, which you can buy from a place like Radio Shack or Menards. With those quick disconnects, you can plug in directly to your battery, which in this case is just a standard 12-volt battery that you'd use to power any of your ice fishing electronics. From that point, it's just a simple matter of turning the lights on and off. By doing your own wiring, however, you open up a lot of options for customization. In my case, I can run as many wires as I want, wherever I want in the portable. If I want to add or move lights or accessories at a later time, it's no problem. The wiring I'm using is 16 gauge stranded landscape wire. You can find it at most home improvement stores for around 25 or 30 cents a foot. The label will read 16/2. For making wire-to-wire connections, I'll use the Ultra Unilock wire connectors that I picked up from Menards. I also grabbed a 1/2-inch PVC conduit body to help organize the wires. The on-off switch I bought was from Radio Shack. The reason I bought it was that it was made for 12-volt power and it had a big snappy switch. I bought the voltage meter from Amazon and have a link down below. Remember that 12-volt batteries don't always output 12 volts. When fully charged, their voltage is greater than 12 volts and they'll dip down below 12 volts as they get close to fully discharged. By memorizing these rough voltages, I can use the readout of the display to know about how much battery life I have remaining. There are two ways of connecting these lights. One is by using the plastic connectors that come in the box, and you can buy more separately. The other is soldering, which I recommend if you have the resources, because it's generally a stronger joint. For either method, you need to first cut the lights and expose the copper pads. On these lighting strips, the only places you can cut are designated with a little scissor icon, which will occur after every 3 lights. The second step is to remove the waterproof coating covering the copper. To do that, I used a sharp knife and just filleted the material off. You had to be pretty careful because it wouldn't be all that hard to cut too deep and slice through the actual light strip. The plastic connectors that come with the lights are pretty easy to use. You just slide the lights into one end and close the cover. On the other end, you could either connect another set of wires or lights, though it would be tough to keep the wires held in place. Now, if you're using your own wire and soldering, you need to first expose the copper of the wires. A wire stripper is the best tool for the job, but you can also get by with scissors if you're careful. This landscaping wire isn't color-coded. Both wires are black, but one of them has grooves in the insulation. It really doesn't matter which one you choose to be the positive wire, as long as you stay consistent throughout your project. I chose to keep the smooth wire positive and the grooved wire negative. You'll obviously need a soldering iron, solder, and flux. My soldering iron is cheap, old, and abused, therefore it's pretty hard to use. You can buy new soldering iron kits that will do this job just fine for around $20 to $50. Soldering creates dangerous fumes. In the absence of an air filter, you'll want to work in a ventilated area and use a fan to keep the fumes away from your lungs. Pre-tinning the wire and light connections will make soldering much easier. Twist the wires, then dip them lightly in flux, which will help the solder stick to the wire. You need to touch the soldering iron and the solder to the wire at the same time. As the solder begins to melt, push the solder into the wire so that it wicks and coats the surface. After that's done on each wire, you can do the same for the lights. Coat the copper with a little flux, then tin the pads. Lastly, you just need to join the wire to the copper pad on the light. Press the wire against the pad with the soldering iron. After a couple of seconds, you'll see the solder begin to flow. Pull the iron away while keeping the components held together. The solder will harden and you'll be left with a good joint. If it does look a bit messy, you can always try again. A very important point is that you don't want the joint from one wire to touch the joint from the other wire in any way. because it'll create a short circuit when you hook it up to the battery. I'll also reinforce these connections with a few wraps of electrical tape. A quick and easy check to see if your joints are good is to touch the appropriate wires to the terminals of the battery. The light should turn right on. For wire-to-wire connections, I'm using these Ultra Unilock wire connectors, which are made for 22 through 12 gauge wires. I can actually stick 3 of my 16 gauge wires into one of these connectors, which I'll need to do for my wire setup. These connectors have threads on the inside, and you can first feed your wires down into the threads. Then you just screw the connector clockwise until it becomes tight, at which point the wires will be locked together both mechanically and electrically. I showed the quick disconnect terminals before. The ones I have here fit 14 to 16 gauge wire, are fully insulated, and have 1/4 inch tabs. In addition to connecting to the battery terminals, I can also use them to connect to my on-off switch and my voltage meter. So really, the only connections I've chosen to solder are the wire to light connections. With this on and off switch, you'll notice there are 3 terminals. One is for the positive lead from the battery, one is for the power going out to the lights, and the third is for the ground. The voltage meter is a little bit simpler. It just has a positive and negative terminal, and I'll wire it in parallel with the lights just after the switch. I'll show exactly how I wired my setup in a bit. Now you essentially have all the skills you need to do your own wiring, and you know all the components to use. The next step is to decide where you want your lights to go. For me, I want lights on the rail directly over my head, and on the rail just behind my head. And actually, I'll have 2 strings of lights straight over my head for a total of 3 long strands. I have the feeling that lights on the rail in front of me might be too distracting. I thought about putting a string of lights underneath my seats to see into the sled better, but the overhead lights are bright enough that it's really not needed. Remember, don't plan on putting the lights on the inner extension tubes, because then you wouldn't be able to collapse the tubes anymore without stripping the lights off. You need to keep the lights on the upper portions of the rails and then run wires down to the battery box. It's obviously important to take all the light and wire measurements before cutting and connecting. Before attaching the lights to the rails, I first clean the rails by wiping them with some acetone. Then the peel and stick adhesive holds surprisingly well. Of course, I wanted to be safe, so I added electrical tape at several spots along the length also. Then I tape the wiring near the lights and near the extension grip with a little bit of slack in between to act as a strain relief. That way, if something catches the wire, it's less likely to pull the solder joints apart. Now I have the lights connected to my flip over with wires dangling down one side. I want my battery box in the middle, and I'll be able to bolt the box directly onto the bench so it doesn't slide around when I'm moving or taking the rig in and out of my truck by myself. A short length of wire goes from the box to the corner of the bench, where I split that single landscape wire into 2 wires, and those 2 wires into 3 sets of wires powering my lights. I had to do it that way since only 3 of the 16 gauge wires fit into each Unilock wire connector. I used the 1/2 inch PVC conduit body type LB to keep those joints connected. Then I simply taped the PVC enclosure onto the bench. While you could drill holes in the rails and run the wires on the inside, I wasn't sure if I'd run into any issues collapsing and extending the rails, so I chose to keep the wires on the outside. The last part of my build is making the battery box. Again, I wanted it to hold the battery snugly when I moved the shack or if I took it in and out of the truck by myself, so I used my CNC router to cut out a tight-fitting pocket out of a 2x4 for the battery box base. Now it can't rattle around. I realize most people watching this don't have a CNC. You could achieve the same effect by cutting a piece of styrofoam to fit in the base of your box with a cutout for the battery. The walls and top of the box were made from 1x6s, and I wanted the top to be a little bit more decorative. So I found a cool silhouette of a walleye searching Google Images. I downloaded the JPEG file, opened it in Adobe Illustrator, auto-traced the contours to export as an SVG file, which my router's Carbide Create software could read, and generated a V-carving toolpath. The router did the rest, which took around 35 or 40 minutes total. It's tough to get a great finish on a soft wood like this, but I'm still pretty happy with how it turned out. The next step was to paint the contoured image black for good contrast. Once the paint had dried, I resurfaced the board on my belt sander. By using sandpaper and a cabinet scraper, I was able to bring out all the fine details. All of the high points take the color of the wood, while the deeper contours remain black. I then added a couple coats of polyurethane to protect the box. Here's my voltage meter and the on-off switch. I needed to create holes for both of these to fit in the top of my box. The way these work is that they have little plastic rings that screw onto the backside and hold them in place. So I cut out these holes so that the components would fit in but not fall through. Then I had to countersink those holes in the backside to give enough room to screw on the little plastic rings. You can clearly tell which one I did with the router versus which one I tried to do with the drill. Once I lock the components in place, they're pretty stable, accessible on the bottom side electrically, but still look clean on the top side. I needed to be able to open and close the box to remove or charge the battery, so I added hinges to one side of the top. Luckily, I'd cut the boards close enough that the lid is a snug fit, meaning I don't need to add a latch. Here's how the wiring schematic looks. If you're trying to replicate, you can of course pause the video and take a screenshot. Here's what the wiring actually looks like in the box. One final touch I made was to add pliers to the front of the box where they'll always be easily accessible. These pliers were a gift from a friend and they came with a pouch designed to clip onto your belt. I made an imitation belt from a couple of picture frame holders from Menards. That allowed me to snap the pouch onto the box, and I no longer have to worry about digging through a tackle box or the bottom of the sled to find pliers right when I need them the most. That's all there is to it. My goal with this was to showcase how I made my lighting setup while at the same time teaching enough that you can do your own custom setup. I hope you enjoyed this video, and if you did, please like, comment, share, and subscribe to my channel.